So for example, we have this. We would go ahead and graph each of these individually on the same graph. So the very first thing that we would do is we would graph it doesn't matter which equation you graph first, it would be the same thing. So we have y is less than or equal to 4x minus 2. And so what I could do is I can go ahead and graph it. So I would first graph the y-intercept, which is -2. So at -2, I'd graph the y-intercept. Then, because of my slope, which is 4x, I would go 4 up, 1, 2, 3, 4, 1 to the right. And if I wanted to go backwards or retrace my steps, I would go 4 down, 1, 2, 3, 4, and 1 to the left. And I can go ahead and connect them. Thank you. So this one, as per yesterday, it's going to be a solid line because there is an equal sign under, right? It's less than or equal to. I want to show you that you can shade under this, but we're going to wait 1 second before we shade. I'm going to go ahead and draw my next one, which is that y is greater than 2/3 x plus 1. So I would draw it at 1 right here for my y-intercept, right? And then my slope is 2/3, so I would go 2 up, 1, 2 over 3, 1, 2, 3. Go down 2 over 3. For this one, it would be a dotted or dashed line. So you can see here that we would shade above the line. So what's interesting is that for this one, we want to see where do they coincide or where do their shaded areas have in common. So again, for our first line, we're going to shade under the line. So if I were to shade under the line, technically I would shade everything under, but I am going to only shade what they have in common. Okay, so below the first line is including this point right here. And then including just I'm going to use a red pen just to distinguish, above the dotted line would be this section right here. So you can see that the part that they have in common is just that little area, but again, it would extend if the graph were to continue to extend. So the only area we have to shade is the common area for both. Okay. Does anyone have any questions? Make sure your mask is on. Thank you. Question?
Why is it only that that's the common area and not like the one below it, you know what I mean? Like it seems like they're similar, but like if you flip it around, it seems like it's
So great question. So I'm going to go ahead, I just want you to see this. This is what they have in common. I'm going to go ahead and shade the rest of it to show you what it would look like. So for example, if I shaded above the dotted line because y is greater than, right, the line itself. So if I were to shade the red area, you can see here, my pen is dying. Doesn't that? It's almost out. So you can see here, if I were just to shade above, the area above the dotted line would be right here, right? If I were to shade below the solid line, you could see here that if I were to shade all of that area, it would be all of this area here. You can see that the only area that they have in common is this commonly shaded area.
It's the only area that's
Shaded for both.
that's greater than the other one, less than the other.
Exactly. So great question, Jacob. Yeah. So you can see here that for this one, everything less than this line is including all of this area. Everything greater than the dotted line is included up here. but the only area that they have in common fulfilling both of those requirements is this tiny area right here. So you could actually shade it like this on the test. That's totally fine with me. But if you want to make it easier for me, you could just shade that area. That's totally fine. But both will be okay on the test. Okay? Does everyone understand what we're doing today? So today we're combining two different inequalities, and then we're just graphing it. Okay? Your only homework is just two sides of that sheet. After that, you're done. Again, once you're done, you can use your phone if you want. Choose to. So Ethan, could you put your feet on the ground? Thank you. I know that it's comfortable, but could you put your feet on the ground? Thank you.